So here we have the two remanufactured joysticks that I'm doing for the one customer. This is where they had purchased palm ones. I had done some heavy dutier ones which used the metal shaft joystick and two different designs, and came up with deciding that this design with the complete encapsulated sandwiched joystick mechanism ended up being the strongest. That is the one of the two that they sent back to me that survived. Now the problem with this one that survived was that we were seeing that it thought that the button was being pushed, and it ended up, once I tore everything apart, and actually this is the board that was in there that I desoldered everything, but this board is still showing the flashing pink and white, and that's telling me it's thinking it should be in boot mode. So there's something up with this board itself. I don't think it was the joystick itself. So that was good and bad, I guess, depending on your point of view. So anyhow, so the core is going to be the same for this. It's got big sandwiches. It uses it. These are M312 screws that will go through here, and this is a two-part plastic part that sandwiches the board, so it holds the printed circuit board, this green part, in there, sandwiched between it. And this is all printed with PETG plastic at 100% infill. So this is pure plastic. There's no gaps or anything inside of it, just for added strength. And did the same thing with all the parts on here. So this is actually quite a bit heavier than some of my other sticks, just because of the mass of the plastic. On the toppers, the brass inserts went well. What continued to fail was the point where the cylinder meets the top inside of the hemisphere. And so what I've done is, first thing I did was I thickened up these walls. So these are considerably thicker than usual, as you could see. And also, these are now printed at 100% infill, so it is solid plastic, which really adds quite a bit of girth to it. And the way that I've tuned the software so that, because of these toppers and they're so low profile, they have a limited range. So the software that runs on the sticks accounts for that. So you still get the full range, it's just a much shorter distance. But by keeping the topper close to the stick, it prevents additional leverage, which would potentially break the stick. And you can, and the nice thing with these too is because they use the brass inserts, is there we go. They switch out pretty easily. So that's the small one. And this part here I only have during printing to stabilize the printing, and actually gets clipped away. You can see on the clear one I've clipped away that support. I can't keep that support there because otherwise it bangs into the enclosure. The other challenge, weird challenge I found with these particular brand of sticks, and it drove me crazy because I built one out and then the x-axis was just completely off the board. And I was like, is my code wrong? Well, it works fine on one, but not the other. All that usual stuff. And I had to pull out the old multimeter, and I measured the resistance across the potentiometer, and it's the resistance, because if you measure between the wiper, the center one, and either the positive or the negative, either one of the outside ones, when it's in the center position, they should show about the same value. So on a joystick, these typically have 10 kilo ohm resistors, so when you do that measurement, it should be about 5 kilo ohms on each side. It's usually not exactly 5. In fact, it's almost never 5. It's more like 4.8 or 4.9. But anyhow, I measured the y-axis potentiometers on this, and I just used my wires to tie into that. I tied my meter, a black wire, and then one of my blue wires, which is the X, and then I checked the positive by doing the same thing with the red wire and the blue. And I found that on three of these sticks, these potentiometers are potentially bad. So I'm really going to have to watch out and make sure that these get tested before I even do any assembly. Now, there is a chance that my board itself is bad, or the soldering of it, but I resoldered this stuff, and these boards have been pretty reliable. I've gone through literally hundreds of them, and this is the first time I've seen it, and it's only happened with this particular brand of stick. Now, the good news is before it's soldered on, I could replace these potentiometers with different ones, better ones, and but still keep the mechanism. But that kind of stinks because this is already a pretty expensive part. This is, versus a standard joystick is about $3 or $4 for the mechanism. This is at least twice that. So I really would like it to work out of the box versus having to retrofit something. So I'm also going to look for a supplier of these from a major electronics distributor, because those are usually more reliable sources for parts. So that's what's happening. So the end of the day, these sticks I think are coming together pretty well. They have been play tested quite aggressively in the field, and the protecting the mechanism has worked out real well. The brass inserts have worked out real well. So once I get a good batch of mechanisms in place, I'm going to be building and making these available. These will be called the Palm Plus sticks. So I'm not going so far as to say that they're heavy duty, because they don't have big steel shafts like an arcade stick, but they are stronger and built more tank-like than my regular palm sticks. They'll be more expensive because of that, but hopefully not too much more. So there we go. That's an update on the Palm Plus. Thanks for watching.